So considering the fact that we have to save the return address when we are executing nested function calls, the poly functions that we've seen before, it's gonna look something like this. So at the beginning, when the like right after the label, when the function is starting, we want to save that return address onto the stack. So this is exactly as what we've seen before on how to save any register on a stack. So we are moving the stack pointer by -4, and we are doing a save board to put this return address to the current location of a stack pointer. So far so good. After that, we are doing the logic that we need to do for our function. And finally, right before we do the jump register or return, so right before that, we have to load this register or any data that we put on a stack. As you see in the next slide, that is not only a return address sometimes, and we have to basically restore all of that back. So some registers have to be untouched, basically. That means if you look at before poly and then after poly, these registers values should remain constant, so they shouldn't change. So here we put it on the stack, and right before doing the jump register or doing a return, we are restoring that from the stack. And this toLine is basically the same instruction that we have seen in the previous week, that we have the load word to read from the current location in the stack pointer and save it to the return address, and doing an add I to fix the new location of the stack pointer. So when you are doing your function, as we said many times, they are independent. So that means that they don't know about the other code or other functions that you have in your code. We have some mechanism that we are following. So basically all these functions can be executed without conflicting. So let's look at this code now. We have a, we are calling the PAW function that we've seen before. We are calling it 2 times. The first time we are putting the return value in temp1. The second time we are putting the return value in the result. And then the final result is going to be temp1 plus result plus 1. For some reason, we are calculating something. So now the question is, which register should the temp1 be in? So it is temp1. Which register we should use for this one? And you can pause the video and think about that for a second. So the temp1 should be in the S registers. So that's again a convention that we have. So S register, or sometimes called as save register, are known that their value gonna be saved before and after a function call. So that means if you're having something on your S register here and you're calling a function, you're guaranteed or you're promised that this S register is not going to change its value after the function call. So that is the power of this register. Other registers are not like that. So here, for example, we are seeing a series of different registers and doing a function. So these are, again, these are conventions, and there is nothing that stopping us from changing these values or not changing these values, right? So we have the full control, but these conventions allow us to basically be able to do multiple functions and nested function and all sorts of things without breaking each other. So if you have these registers and they have some value, after calling this function, we are seeing the result of these same registers. So the S0 had 13, and after that we know that it's gonna have the 13 still in it. But A0, V0, or T0, or in general A, V, or T's, they could lose their value. So we should assume that this function is going to change these values. So basically that's the convention that we are following. The only thing that this function is not allowed to change is the S register. And everything that you want to save, you should put it in the S register before calling the function, because you could lose their value. So this is a general rule. This is some conventions that we are following. The A, V, and T, they are not preserved across function calls. So that's what we saw. RA, the return address, is also not preserved. So if you have some values in these registers and you're calling the function, you cannot be sure that after that function, you still have your values in these registers. S registers is the opposite. S registers are preserved across the function call. So something you have before here in the S register, after doing the function, you can be sure that still its value is there. So suppose we are writing and translating the function. If S is used as a local variable in F, what can we do? So imagine in your function, for example, in the poly function that we talked about here. So this was the poly function. Imagine you need to use the S register here, but since we saw the convention, you should not change the S values. So what is your option? What should you do? So the solution is that basically to save your S register also on the stacks, same way you are doing your return address. And then at the end of the function, you can restore the same value that was in the S and put it back in those S registers. And in that way, the before and after function gonna be the same. So we are using a stack as kind of like a temporary placeholder for these values. So here we are putting basically just what I said. So two values, we are putting it on our stack. So before, if you remember, we had only the RA and we were putting that on the stack. So now here we are actually doing two values on the stack and running our code and the logic for the poly function. And then at the end, we are restoring these two values back to where they were before running this function. So we are restoring the RA and we are restoring the S1 and updating the stack pointer. So basically, you are keeping your state. And the other thing to note here is that you should be careful about the order of items that you are putting on your stack, because you could put it, for example, S1 and then R1. And then when you are restoring those, you could like flip them by mistake. So you load for example, S1 to R1 and then RA to S1. So just you should be careful that where you are putting and in which order you are putting your variables onto stack, and you basically pop them in the same order. Otherwise, this basically everything gonna get conflicted.